Yeah, this is great. This is a long time in coming. I'm very excited for what these gentlemen are going to share. So, just briefly, to give them an appropriate intro, Dr. Kylie and I are always endeavoring to push the envelope and to help you as clinicians have the best clinical outcomes as possible. Trying to make protocols, programs, as you're making your decisions, trying to make that as simplified as possible. And so Francois, the Chief Executive Officer of Evidence-Based Supplements, is here, and he's going to shortly share his presentation with you. And I'm excited as he goes through those slides. This is going to be super informative. Dr. Sam Fortin also is their Chief Scientist, and will also be sharing some information as well. So both of these gentlemen have worked in the natural products industry for many years, to say the least. And I've had former experience with them, and I can attest to just their level of integrity. And our relationships, our business relationships we reconnected this last year, and I was able to see what they've been working on. They put a lot of time and energy into preclinical studies. They've done the legwork. They've been able to do a lot in terms of the research and development in these omega fatty acids, and they're going to explain it more where it will make more sense. So I'm most excited about their level of research and clinical data. They've gone through all the beta testing, all the preclinical work to validate these effective products. And that's why I'm considering using these and incorporating these and suggesting these into the majority of programs that I recommend, protocols, and they'll explain that a little bit more. So without further ado, Francois, I'll let you take it from here.
Thank you so much, Mike. Great introduction. Really, really privileged. I feel privileged to be here today and have a chance to share everything that we've done in our products and our company. So I know I really, really appreciate it. So listen, I've got a presentation. It's probably 45, 50 minutes approximately. We do have a lot to go through today. We are focusing on our MAGO3 product, and I'm going to start sharing my screen. So we're going to focus today on the MAGO3 product line. But first, I want to talk about the team, the EB Supplements team. Myself, François-Karl Brouillette, the CEO and co-founder with my other partners of EB Supplements, the brand. I've got more than 18 years of experience in the dietary supplement field. My experience goes from quality assurance, operational, but product development and clinical research, marketing, and business development. And with my partner, Marc Vaugeois, our current Chief Business Development Officer, we had founded a company called BioJoga, which we recently sold to another group, where we were basically developing products and making products for other branded companies, namely practitioner or companies that sold in the practitioner channel, including because we've done products for many, many different branded companies. So our expertise is mostly in essential fatty acids. That includes omega-3, obviously, omega-3 fatty acids. And during my time as a product development officer there, I met Dr. Fortin back in the days. It goes back a while now. And where Dr. Fortin had developed is omega-3 monoglyceride omega-3 technology, which is the MAGO3 technology that we're going to talk about today. So we're fortunate enough to have the founder and the inventor of the monoglyceride omega-3 technology. And Dr. Fortin, we split the presentation in two. I'm going to talk about the technology itself, what is it, why is it so important and effective, and then Sam is going to take over about the clinical research that he's conducted throughout the years. And we have Marc Vaugeois, which co-founder as well. Marc Vaugeois has tremendous experience in the B2B and B2C in the dietary supplement in North America. He has, and he's been my partner at BioJoga, now my partner in EB Supplement as well. So EB Supplement is a Canadian-based research-driven dietary supplement company. Our mission really is to deliver clinical and scientifically sound approach to the healthy aging market, leveraging our cutting-edge technologies and our IP portfolio, which all of our products are developed through clinical research. Dr. Fortin has two different research centers where he can conduct ex vivo, in vitro, preclinical, and also human clinical studies. And so all of our products are being investigated either by human clinical studies and preclinical or just preclinical. So we'll go over our portfolio that has been developed through human clinical studies. And so we have an extensive intellectual property portfolio that includes licenses and patents that are covering the globe with our technologies. And we have, like I said, many, many years of product development expertise, which we're now obviously leveraging in developing products for you guys. So EB Supplement, like I said, today we're going to focus on our Mago3 product line. It's our Mago3 Omega-3 solution, and we're going to talk about how it's made, why is it so efficacious. And it's been developed and clinically studied in Canada. It's patented worldwide. And basically, in a nutshell, it's a enzymatically treated or pre-digested, as I like to say, omega-3 rich fish oil, which basically optimizes its absorption, and namely the absorption of EPA DHA. So we're going to talk about more detail what it is and how we're making it and why it's superior than your regular omega-3 that you can find on the market today. EPA DHA. So really to understand what Mago3 is and why it's so important and why it's so efficacious, we need to just go back really quickly on what EPA DHA are. They're basically essential fatty acids, right? Even though you can synthesize them in your body, it's really, really poorly synthesized. It's really hard. Our bodies are really having a hard time making EPA DHA out of what we eat. So usually or normally, you need to take EPA DHA from your diet, either from eating fish or by taking supplements. And we're going to see a bit later why taking supplements is really important. And what happens when you take EPA DHA, while it can get stored as it is or as is in your cellular membranes, which are obviously you can find throughout your whole body, obviously in your organs, it's really important to pack those cell membranes with EPA DHA, but your body can also metabolize them in different metabolites. And the different classes of metabolites are classical icosanoids, which are anti-inflammatory metabolites, but also non-classical ones, which are basically, which can lead to, are composed of lipoxins, resolvins, protectins, which are also really important anti-inflammatory metabolites. And you can also metabolize them into endocannabinoids, which really have an important role in mood behavior and inflammation as well. So really important molecules, and the omega-3 really you want to focus on is the EPA and the DHA. Those are the most important one. We're not going to talk about a third one, which is DPA, which also is important, which also we have in our products. We're really going to focus on EPA, DHA and their importance. But I kind of assumed from the get-go that you already have a good knowledge of EPA, DHA, good knowledge of omega-3, but obviously, so we're not really going to spend too much time on those. We're really going to talk about the technology and how it compares to regular fish oils. But we are going to say that omega-3 fatty acids are ones of the most researched molecules in the world. When you compare them to even some pharmaceutical products, you can see that we've started to study them in the 70s or late 70s. And since then, we've done thousands and thousands of clinical trials, human clinical trials that have been conducted with omega-3 molecules. So one of the most studied ones, and they have been demonstrated to be super efficacious and really important in many, many different conditions. So what I wanted to do today is not necessarily talk about the science of EPA DHA and the clinical studies of EPA DHA per se. I really want to focus on our Mago3, as I've said. And I think for you guys to really understand why it's different and why it's so important, and how it compares to and why it's so superior than regular omega-3 fish oils is to understand how fish oils are made in general, and also to really understand what's out there. What can you find in the market today in terms, because there are different types of EPA and DHA out there. It's really important for you guys to understand the differences. So this slide really explains those differences. So really, to start from the beginning, start with a fish. What happens is you take a fish and then you extract and you purify the oil, because there's really three phases in a fish, right? There's the solid phase, the water, the aqueous phase, and the oil phase. What we do is we take out the oil phase and then we refine it, and that gives us triglyceride fish oil, because naturally the fatty acid that really composes the oil comes into a triglyceride form. And what triglyceride is, it's really three fatty acid attached to the glycerol backbone right here. So this is a glycerol backbone or glycerol molecule, and you have three fatty acids that are attached to this glycerol backbone, hence why we call it triglyceride. So those would be your common cod liver oils, salmon oil, anchovy oil, tuna oil. Those are the ones you're going to find. So they're really low omega-3 concentrated oils that you'll find on the market. Okay. So, but throughout the years and with more and more research, we figured that we understood that we need to have a lot of omega-3s in order to really, really reap the benefits of omega-3s. And to do so, the industry was pushed to concentrate the levels of omega-3s into the oils. In order to do this, we needed to separate the three fatty acids that were attached together, because otherwise you can't really, if you want to concentrate this one, for instance, well, you got to remove those two and detach them, isolate this one in order to be able to concentrate it. So what they did is they basically took it. This is old chemistry, right? It's really, really old chemistry. It was quite easy to do in the industrial scale, but the challenge was not to decompose the oil or degrade it while doing this process. So we figured out ways to do this really nicely. So we can do all of those processes while keeping the purity and the quality of the oil at a really high level. And as the years went by, we refined those processes and got better and better at doing it. But what we want to do here is we want to take the triglyceride molecule and we want to transform it. We want to detach the fatty acids and make what we call ethyl esters. Because what we do is by detaching the free fatty acid, we don't want to leave it free because it's quite unstable. So what we want to do is reattach it to an ethanol molecule, which gives us an ethyl ester. Hence why it's called ethyl ester, because of this little ethanol molecule that's attached to this now free fatty acid or esterified fatty acid. So this esterified fatty acid, ethyl ester, now we've succeeded in isolating the fatty acid that we want to concentrate, but we also reduced its size as a whole, which makes it much easier to evaporate because it's got a molecular weight that's much lower now. So you have to apply a lot less energy to be able to evaporate it. And this is the process that we use, the distillation process, to concentrate, to isolate and concentrate different fatty acids. And the one that we wanted to keep are the omega-3s. So the ethyl esters, you'll find them on the market. There's multiple products that are out there on the market. And those are the high concentrated omega-3 fish oils. So the ones that has more than 60% EPA DHA content. Those are generally in the form of EE for a number of years. And lately, in the last 10, 15 years, a lot of companies took it a step further. And what they did is they took this ethyl ester fish oil and they re-esterified it into triglyceride. So basically, they did pretty much the same thing where they detached the ethanol molecule and they reattached the fatty acid on the glycerol molecule and they did it 3 times. So they reattached 3 fatty acids on the glycerol to rebuild a triglyceride. Okay, and we call this re-esterified triglyceride fish oils. So there's really 3 types of fatty acids or fish oils that you can find on the market today. You've got your natural triglycerides, which are low EPA DHA concentrated oils. You've got your ethyl ester fish oils, which are the high omega-3 concentrated fish oils. And then you have the reesterified triglycerides, which are ethyl esters that were recombined with glycerol to make a triglyceride. Well, you got to know that this reesterified triglyceride molecule or fish oil is not 100% TG. Typically, it's going to be around 90% or 95%. And what you're going to find is, because it's really hard to bring that conversion to completion. And how it happens is, in order, you got your glycerol molecule and you start attaching one fatty acid. And at that point, you get a monoglyceride. Mono, one, glyceride. And then you attach a second one, which gives you a diglyceride. Two fatty acids, diglyceride. And before attaching the third one, which gives you your triglyceride. So because it's hard to bring that process into completion, you'll have a mixture of all those fatty acids in the oil. Most predominantly is the triglyceride at 90% plus. And then you'll have a tiny bit of mono, which is 1 to 2%, and a little bit more diglyceride, which can go from 2 to 7% approximately. So just remember that RTG, which we like to call RTG fish oil, the reesterified fish oils, is not 100% triglyceride. Get a mixture of all of those. The RTG is the most popular fish oil on the market today in North America. That's the most popular one. That's the one that you'll find the most. But it depends on the channel. Like, for instance, pharmaceutical products, they're mostly ethyl esters. Those are the most predominant form of fatty acids or fish oil in the pharmaceutical products. But when you take a look at the dietary supplement, RTG probably is 60 to 70% of the market. So now that we know we have 3 different types of fish oils, a renowned researcher in the field of omega-3s, Dr. Dyerberg, conducted a study. He asked himself, well, do they behave all equally? Are they all absorbed equally? If we start comparing TG, RTG, EE fish oils, are we going to see the same rate of absorption between the different types of fish oils? So the answer is no, they are not equal. They are not absorbed equally. And the difference that he saw was that the RTG was actually better absorbed than the TG fish oils, the natural triglyceride fish oil, which was interesting at back then. The question Dyerberg asked himself was, why? Right? I mean, what's the difference between a TG and an RTG? He also saw that the ethyl ester was the one that was least absorbed. And that was not too surprising, because we don't necessarily find ethyl ester in the nature. So we're not really built to, we don't have the right cocktail of enzymes to be able to digest the ethyl esters. We can do it, but it's a little bit harder to do it than a triglyceride. So it is the one that is less absorbed. But the difference between the RTG and TG really baffled Dr. Dyerberg at the time. And if you look at his publication, his hypothesis was that actually the fact that RTG contains monoglyceride, it actually helps. Monoglyceride has an impact, a positive impact on the absorption of the TG omega-3 fish oil in general, and hence why it is better absorbed. So just by the mere fact that you have some monoglyceride in there and also some diglyceride, it helps the absorption of the omega-3 that are contained in that oil. And we're going to see why a little bit later. So remember this study, RTG better absorbed than TG because of the presence of monoglyceride omega-3s. That was interesting. So with the years, a little bit during the same time as the Dyerberg study, Dr. Harris also conducted his own studies, and he saw a correlation between the levels of omega-3 that we have in our cells versus the level of the incidence of cardiovascular health conditions. And his hypothesis was that the more omega-3 fatty acid you have in your cells, the less chance of cardiovascular health diseases you're going to be inclined to get, or to be afflicted by. And he actually was able to demonstrate this this correlation. But not only was he able to demonstrate it, he actually developed a tool to be able to measure the amounts of EPA DHA that you have in your blood cells, in your red blood cells, in your cells in general. But his tool was to look at the red blood cells. So he's actually selling a kit now, which is something that you can talk to Mike and Dr. Kiley, and they can talk to you about it and make it probably available to you guys. But this is something that we call it the omega-3 index. And there is a kit that allows you to measure the omega-3 index, which gives you an indication of the levels of EPA DHA that you have in your body, which is directly correlated to cardiovascular health, which is a super powerful tool today. So the way it works is when it measures the percentage of EPA DHA versus the rest of the fatty acid that you have in your cells, in your red blood cells. And he's, with the correlation, he was able to say that if you are above 8%, you are at the desirable range or the desirable level of omega-3 in your body in order to be able to be at low risk of developing cardiovascular health diseases. If you are below 8% and above 4%, you're in the intermediate range. And if you're below 4%, which is most of North Americans today, you're in the undesirable range. So at a high risk of developing cardiovascular diseases. So this is super important. This is really, really important. And it gave, at that point, it gave practitioners a tool to be able to measure the omega-3 levels in their patients' red blood cells, but also to correlate to cardiovascular health diseases or risk of. And with this analysis being offered to the population, after years and years and years of collecting data, they started to publish some of the analysis that they had conducted on their data, their database. And one of the publications that is really interesting, because when they actually test their subjects or the population, the customer always has to fill a questionnaire. They ask them, okay, so how many fish meal do you eat per week? Do you take an omega-3 supplement? And what type of omega-3 supplement do you take? And they correlated and they analyzed all of those results in conjunction with the actual omega-3 index levels of all of those patients. And they basically published really, really interesting data, which basically tells us that, in a nutshell, even if you're eating 3 fish meals or more per week and taking omega-3 supplements, you're only at 44% chance of being or having an omega-3 index of 8% or more. So this was really interesting because we always keep saying, back in the days, we always said, well, I mean, yeah, omega-3 supplements, do you really need to take them? Well, if you eat a lot of fish, which not a lot of North Americans do, but if you do, then maybe you're okay. Maybe you don't need to take supplements. But if you do this, we realize now you're only at 23% chance of having an 8% omega-3 index. And then even if you take your supplements, you're going to be at 44% chance. So there's a problem. There's really a challenge here. There is a problem that was identified with this study. And I think it kind of makes sense when you start to think about, okay, so what are omega-3s? They're oil, right? And we know, oil doesn't really get well absorbed in our body because we need to process them. We need to process the oil in order to be able to integrate them in our body. And then fatty acids, you need to break them down. You can't just absorb them like that. So there is a challenge. And we have identified through many studies that fatty acids absorption is suboptimal. It is not optimal. And because we only absorb 65% of the oil that we take if we take it with a meal or as a supplement. And that's in the triglyceride form. Forget about ethyl esters. Ethyl esters is really much less than that. Now, obviously, this varies, okay? So this varies. This will be impacted by many factors. For instance, if you take it with a meal, if you take your omega-3 supplements with a meal, you'll increase the absorption rate. It'll help because then you take in food. Food triggers the production of bile, triggers the production of enzymes. It really, really helps to process those fatty acids that you've ingested and helps the absorption overall. So taking omega-3s with food is really important. It's something that I think is very important. And we know that oil doesn't mix well with water, right? I mean, it just doesn't. So, and our body is mostly composed of water. And that's our digestive system as a whole. That's the gastric fluid, the intestinal fluid. It's all, it's all water. So basically, when you take an oil, it doesn't mix well with water. So we had to find ways to be able to integrate those oil and be able to process them in order to be able to absorb them, because otherwise you just can't absorb them. Impossible. So the way we do this as humans, first step will be to emulsify the oil. Just help the integration of oil into our digestive system. And we do this by using bile salts. So we produce bile. Bile comes with the oil. It creates micelles. It emulsifies the oil. And that means emulsifying means bridging oil and water. So emulsified or emulsifiers agents will like to be both in water and oil. Okay, and bile salt is like that. It acts much like a soap, for instance, right? So it helps the integration of oil into our digestive system, where now in the gut we can digest the fatty acids. Like when you take triglyceride, for instance, you got to break down that triglyceride molecule. It's too big, can't absorb it like that. And when you do digest it, you'll end up with free fatty acids, but you'll also end up with monoglyceride omega-3s or monoglyceride fatty acid right here, which both of them can now be absorbed in your body, in your bloodstream. And then it can get metabolized or it can get transported into our cells. So this is really important to understand. So there's a huge problem because the integration of oil and the digestion of it, really, it's complicated, right? And this really, the impact is that we can't get to 8%. It's really hard to get to 8%. You can take a lot of fish oil, eat some fish, and then really, really try to optimize the levels every day. Take a lot of omega-3s in fish oil. But even then, it'll be hard to get to 8%. And if you do, getting past that 8% is even harder. So what's the solution? Well, solution is what Dr. Fortin actually developed, which is our MAGO3 technology. And it's a real solution. It's something that we've not only studied in labs, in preclinical studies. We've done tremendous studies, like many studies, dozens of studies, preclinical. But we've moved beyond that by doing human clinical studies. We've got more than 15 clinical studies now conducted with our material, with 25 plus publications and 25 plus approved patents and protected in 11 countries. And we launched this technology ourselves with EB supplements late last year in the US. And we are now also sold in Canada and in South Korea. So we're having tremendous success with this technology. It's really, really impacted a lot of different, and the greatest feedback that we're getting is that finally we can have an impact on the omega-3 index. Finally, we can get our patients up to 8%. And we're going to see how it works. So basically, what is MAGO3, right? Well, MAGO3 is a fish oil that's concentrated in monoglyceride omega-3. It's basically that. So we've gone from triglycerides to ethyl esters to RTG, and now the next generation, right? MAGO3. That's really what we are. And what we've done is we've taken a high concentrated fish oil and we've enzymatically treated it. We did exactly what you guys would do. If you take omega-3 fish oil, you're going to have to digest it. And so what we did is we took the same enzyme that we're using, which is lipase, and we've applied the enzymatic process on the highly omega-3 concentrated fish oil, and we kind of pre-digested it for you guys, so you don't have to do it. So basically, we put that in a soft gel, and then when you take it, what you get is loads of monoglyceride omega-3 fish oils or fatty acids. And the key features, and I've highlighted the molecule here, right? We've talked about it earlier. One fatty acid on the glycerol backbone. This is what your body will produce when it digests triglycerides. That's exactly what you're going to end up with. And this is directly absorbed, so readily absorbable, but it has the benefit of being an emulsifier or an emulsification agent, because you've got this part of the molecule that really likes water, loves water. Glycerol is soluble in water. And then you've got this part of the molecule which loves fat, lipid. So you got that molecule that has part of it that loves water and the other part that loves fat. So it really acts as an emulsification agent. So what does that mean, right? Well, you've got your regular absorption pathway for omega-3s or triglyceride molecules, even ethyl esters, and our MAGO3 basically bypasses this whole system, right? So you don't need to emulsify it, and you don't need to digest it. It's directly absorbed. So that's the technology itself. And being an emulsifier makes it super powerful, because pre-digested, directly absorbed, I think we all get it, amazing. But the fact that it's an emulsifier, now you can think of, oh, okay, wait, maybe it can help the absorption of other liposoluble molecules like vitamin D, vitamin E, lutein, CoQ10, curcumin, vitamin K. So all of those, theoretically, if we put them in contact or in combination with our MAGO3, the MAGO3, by its emulsification power, will help the integration of those molecules into our body, digestive system, and help either they need to be digested or they need to be absorbed. And by being emulsified, pre-emulsified with our MAGO3, then they can be absorbed faster at a greater rate, right? So theoretically, that makes sense, because now MAGO3 is a nutraceutical delivery system for other liposoluble molecule. Well, we've been able to demonstrate this with human clinical studies as well. So for EB supplements, what we did is we developed two products. We've got our daily omega-3 product, which is the one that you take every day. And at the end of the presentation, we have a table with our recommended usage and dosage. But for now, just know that the daily omega-3 is it's a combined, it's an EPA and DHA combined dietary supplement. So it's rich in both, basically. It's about 45% EPA and 20% DHA. And then we have our MAG-O3 MAG-EPA concentrate dietary supplement, which is a MAG-EPA rich or EPA rich supplement. So anti-inflammatory and other purposes, which we'll talk about also later. But know that it's concentrated in EPA. It's about 70% EPA. So those are the two products that we are presenting to you guys today. And we've conducted multiple human clinical trials on those products today. And I'll leave it with Sam to go through the trials. And Sam, if you need any help or, just let me know and I can jump in. But I'll let you take it over from here.
Okay, great. Thanks, Frank. Hello, everybody. So I will talk about all the human clinical trials, the most relevant one and the one that is ongoing. So basically, the proof of concept that we did several years ago was performed on a cystic fibrosis patient, because we're talking about, colleagues and say, what would be the worst condition that for lipid absorption in human? And one of my colleagues said, oh, it's cystic fibrosis, because all the tract are filled with mucus and no bile salt can reach, the digestive system. So they have to take with their meal their enzymes. So I say, okay, so let's try to ask if it's possible some people with cystic fibrosis to take our monoglyceride, but without any enzyme, just to see how the monoglyceride can be absorbed naturally without anything, without bile salt, without enzyme, nothing, just the monoglyceride. So basically, we set up a clinical trial. So we recruit a group of cystic fibrosis patients, and we compare the omega-3 fatty acid on the red blood cells from the patient and from healthy subject too. So basically, as you can see at T0, especially the DHA in red blood cell, it's a lower extent than the healthy subject. So it's below 4%, and our healthy subject in North America and Canada, it's about 5%. So that was the starting point. So it say as a primary endpoint for the clinical trial, let's try to correct this imbalance. So let's just try to take the cystic fibrosis patient and reach their DHA to the healthy subject level. So that was the ultimate goal of this clinical trial. So we performed the clinical trial. It was a placebo control. So half of the group received a placebo, and the other half received a MAG DHA at 4 grams a day. So we start at a pretty high doses because at the time we had absolutely no clue about the absorption. So we start the study. We said, okay, we'll have a T0, a month and 2 months, because on the literature, we saw that the steady state of omega-3, it's about 12 weeks. So about, 2-3 months. So let's say we said about 60 days. So at the end of the study, we analyzed the omega-3 index and especially the DHA in red blood cell. And we saw an amazing results that early at 1 month, we are able to reach the DHA at up to 7% in red blood cells, way beyond the healthy subject. And it keeps increasing at least at 8%, just the DHA. So as you remember, omega-3 index is the sum of EPA and DHA. So they have in their membrane at least 8% of DHA plus EPA. So they easily reach the omega-3 index of 8 without any enzyme, because we said to the patient to take the supplement at night, just before bed, and took their regular enzyme with meal, because it was impossible to ask them to stop their enzyme during 2 months. So basically, it was the first proof of concept that we are able, in human, to absorb the monoglyceride as is, without anything else. And we are able to correct the imbalance. So more than correct the imbalance, we supplement the cystic fibrosis patient, and they are at a level of, way better to be in a position to reduce their inflammation, because inflammation, it's a huge thing in cystic fibrosis. So with this proof of concept, we compare our monoglyceride with the 2 other forms that are currently on the market, as Frank told you a couple of minutes ago. So they are RTGs and ethyl ester. So we know that the ethyl ester is the less absorbable one. RTG, as Professor Dyerberg said, it's better absorbed than ethyl ester because they have a small amount of monoglyceride. But we compare in the clinical trials. So it was a triple-blind clinical trial. So we took a group of healthy volunteers, and there was 3 products with the exactly same concentration of omega-3 fatty acids on all 3 formulations. It was made from the same starting material. So we made a batch ethyl ester, the other one RTG, and the other one with our technology MAGO3. So basically, when you analyze the 3 regimen, it's in the amount of omega-3, it's exactly the same. So every person receive for 1 doses of one of the 3. After this, 2 or 3 weeks later, they come back and we gave them the other one, and 3 weeks after the other one. So every subject received the 3 products at a different time point, and we are able to compare the absorption. So we compared the absorption over 24 hours. So we took regular blood sample over 24 hours, and we integrate the curve, and it's gave the amount of omega-3 fatty acid that are absorbed over a 24 period of time. So the result was always is beyond expectation. So we are pretty sure that it will be better than the ethyl ester, but we are way better than RTG2. So we are 3 times more absorbable than the ethyl ester and 2 times the RTG. So that means that for the same amount of omega-3 that you take on different form, you get 3 times more on your bloodstream or 2 times more than RTG. Or if you look at it on another way, to have the same amount in your blood, you can take half the doses as RTG or 1/3 of the doses of the ethyl ester. So that was published in a very fine journal. So it's all the data are available. So basically, it's the first benchmark from our MAGO3 to all the other omega-3 fatty acid currently on the market. After this, so we look at this was on a 24 hours, so just, acute absorption or pharmacokinetics. So after this, we say, okay, it's just one day. So what if you took, the supplementation every day for a longer period of time? For example, for a couple of weeks, 8 weeks in this time. So in 2 months, approximately the same, time frame that the previous cystic fibrosis clinical trial. So we took the same three products. We asked another group of LT volunteers to take on the daily doses of 3 soft gel, so about 1.3 gram total omega-3. So they receive the same daily amount of omega-3, and we look at the omega-3 index over time. So after 8 weeks, only the MAGO3 group can reach the recommended level of 8. Both ethyl ester and RTG fail to attain the 8. So whatever you take, RTG or ethyl ester at a normal dose of 1.3 gram, you cannot reach 8 of omega-3 index, only with the MAGO3. So it was the second, proof of concept benchmarking over a longer period of time that we call it for maybe the steady state. So what will be the steady state of the omega-3 in my cells after a daily supplementation of a specific doses combined with, of course, all you can eat. So it was a second proof that the MAGO3 it's better than all the other fish oil currently on the market. After this, we went a little bit more precise on the action of the omega-3 is the omega-6 to omega-3 ratio. So it's good to have a wonderful omega-3 index, but if you look at for an healthy person, it's all right. But if you look at inflammation resolution, anti-cancer effect, you have to take to account the amount of omega-6, because the omega-6 is a pro-inflammatory fatty acid, and the omega-3 are the pro-resolution of inflammation. So you have to get a good balance of two, because inflammation is a good process. You don't want to kill all your inflammation process. You just want to resolve the inflammation. When the inflammation is triggered, it's good to have inflammation, but after this, the omega-3 should take the relay to cool down the inflammation. And this is the ratio between omega-3 and omega-6, because our body uses the same enzyme to convert arachidonic acid or EPA to form the metabolite of arachidonic acid are pro-inflammation, and the metabolite of EPA are pro-resolution. So you must have a balance of both fatty acid on your membrane, and when the inflammation is triggered, the same enzyme will metabolize arachidonic and EPA at the same time. Arachidonic will act very fast to trigger the inflammation, and after this, EPA will calm down the inflammation by resolution the inflammation, maybe a couple of days the day after. So you have to keep your ratio healthy. So the literature, it's about 2 to 3 to 1 on the omega-6 to omega-3. Most of the people that we test start at about 15 or 20 in ratio. So the ratio, it's very too high in omega-6. So we asked another group of volunteers to take in this time the EPA concentrate, because we look at the specific ratio of EPA against arachidonic acid. So we took our MAG EPA concentrate and we supplemented for 6 weeks. And we see that only 6 weeks we can reach with our MAG EPA an healthy ratio at about 2.65 to 1 in 6 weeks, versus the ethyl ester was about 5 to 1. So you see an increase from maybe 15 to 20 to 1 to 5 to 1, but it's not enough. You have to use our MAGO3 to be able to reach the optimal ratio of arachidonic acid and EPA with a reasonable amount of soft gelatin. So, as Fran said, the unique characteristic of the monoglyceride is that it's an emulsifying agent. So we are able to take this wonderful, characteristic to dissolve CoQ10 and vitamin K, MK7. So they are all lipophilic active agents. So when we are dealing with a lipophilic active agent that are poorly absorbed because there is no solubility in water, you can dissolve those vitamins in our monoglyceride, and it increases the bioavailability on the same way that we prove it, on the same way that we prove it the 3 times more absorbed than the fatty acid itself. So with CoQ10, we have 3 times more the absorption over 24 hours. And for the MK7, we have a 10 times, 1 log more absorption over 24 hours. So this is just a couple of examples, but we have other examples that we can formulate lipophilic active agent with our monoglyceride to increase their bioavailability. For example, CBD, we have data that will be published maybe next year's, and other lipophilic active agent, curcumin, we have it too. So when an active agent is liposoluble, it's possible to dissolve it in our monoglyceride, and it will help the emulsification, and it will help the absorption of the lipophilic active agent.
That's true. I mean, we do have data on the CBD preclinical, which we haven't put here, but we definitely should update that slide. We get was it 2 times more or twice the amount, or 3 times? I can't remember.
2 times, yeah.
2 times, yeah.
Compared to another oil formulation, MCT oil. So right. It's 2 oil formulations. So it's better than the powder, and it's 2 times better than the MCT oil formulation.
So those are good examples of how MAGO3 can act as a nutraceutical delivery system, which is we think is really powerful, because then you can use MAGO3 as a platform with your patients, and not only as a good omega-3 delivery system, but also to enhance the absorption of other liposoluble nutrients. Thank you so much, Sam. And this is it's not the extent of the human clinical. Those are the ones that we've selected to show to you guys today, but there are more clinical studies that have been conducted either by our group or other groups as well, with whom we've collaborated in the past and are still collaborating with. And so those, I've put all the references at the end of the presentation. So if you guys want to go see it, but you can also obviously visit our website. We've got a clinical program. If you sign up with us, you get access to the clinical program page, which really highlights the major clinical trials that we've conducted, but you also get a glimpse of the preclinical studies that were a prelude to all of those human clinical studies. And I think that the one that we're not talking about now, which probably would require a whole other webinar, would be the one that for a cancer research study with 125 patients afflicted with prostate cancer, which is a study that we've completed, and we're now in the process of publication phase, where we've published 5 publications, and we have multiple manuscripts that are being peer reviewed right at the moment and should be published in the coming years. But results are really, really positive, and we're really, really excited about this. And the coming publications are going to be the ones really highlighting the most important results that we've been getting. But we can give you a glimpse of those, obviously, if we connect together, but maybe in a future webinar. But obviously, if you have any inquiries on those researches, just ask away, of course, and we're here to help. This slide really talks about the sustainability aspect of our oil, but also the quality of the oil. The oil is Friend of the Sea certified, which means that it has been fished in a eco-responsible fishery, where the local quotas have been respected, but also the local communities have been respected also to the harvesting and the manufacturing process. So the whole supply chain has to be certified. So we're really proud of this. And the certified IFOS certified 5-star. Every batch is certified 5-star. IFOS is the international fish oil standard. It's a level up in terms of standard, quality standard versus governmental and industry standards that we need to follow anyway. But we decided to go one step beyond, and it also offers some transparency where if any of you guys or any of your patients wants to have access to the certificate of analysis of every batch, they're all listed on the IFOS website, which you can gain access through our own website. Or if you go on the quality assurance page, you can enter the lot number of our product and you'll gain access to their certificate of analysis. So this gives transparency to the consumers. And I think it's something today that is very important. And what you'll see on the certificate of analysis is all the testing that relates to the contaminants, but also to the levels of EPA, DHA that are contained in our product.